So this is Unit 4, Section 4, and today we're going to go over some proofs that have to do with proving that proving that a quadrilateral is a parallelogram. I want to remind you guys that we have a quiz tomorrow, and it's going to cover predominantly 4.1 and 4.3. So all the properties of parallelograms being used in a drawing, and then also what proves that something is a parallelogram. So number 1 here says, given that WY is parallel to YZ and WX is congruent to WZ, prove that WXYZ is a parallelogram because one pair of sides is both parallel and congruent. So now we're proving that it is a parallelogram given the information that one pair of sides is both parallel and congruent. So our first piece of information here was given, and then we're going to construct again a line, some diagonals basically, in the drawing. Then we have on here YWX is congruent to WYZ. I can't talk today, obviously. So let's go ahead and mark those in our drawing. YWX is this angle right here. YWX, remember YW is one side of the angle and WX is the other side of the angle. And then we've got WYZ. So WYZ is this angle here. Remember, WY is one side of the angle and YZ is the other side. So those look like alternate interior angles to me, but let's do the other pair as well, just to double check. So then we have WXZ. WXZ is this angle right here. And we also have YZX. YZX is this angle right here. So now we have that. I can see, hopefully you guys can see, that we have two triangles that are congruent here. We have this triangle that is congruent with this triangle. And we already had tick marks on the outside, so hopefully you can see that it is angle, side, angle. That's why the triangles are congruent. So we're going to then say triangle XVW is congruent with triangle ZVY. And again, make sure that you're moving from the same number of ticks. So notice on the X we have 2 arcs. So we're going to go with Z because it has 2 arcs. And then we're going to V, which has none, and to V, which has none, and then to 1 and 1 for those. So then, if we've said that 2 triangles are congruent, and then we start talking about the corresponding parts of those 2 triangles, that would be CPCTC. Because again, remember, we're saying corresponding parts of triangles are congruent because the triangles are congruent. So then let's mark this, XV and ZV. Those are corresponding parts of those 2 triangles. Let me put 2 ticks on here since we already have 1 tick. And then we have VW and YV. So I'm sorry, I said WV, sorry, and YV. So then it's talking about vertical angles, right? And if you look at step 7, it's talking about the top triangle and the bottom triangle. So where would the vertical angles be then if we're talking about the top and bottom triangles? They would be right here. So hopefully you see that those are your vertical angles that we're going to refer to. So let's go ahead and put those in our proof. And remember, when you guys are doing these, you're always going to have a bank of answers. So then now look at the top triangle and the bottom triangle. Hopefully you can see why these 2 triangles are congruent. So here we have side and then angle and then side. So those 2 triangles are congruent because of side, angle, side. Then again, we have CPCTC. Now remember, what we're trying to prove is that this is a parallelogram. What we need to prove is that the other pair of sides is parallel. So to do that, we could use the converse of alternate interior angles theorem, right? So we would say that this angle up here is congruent with this angle down here. That's what we do, because that would then prove for us that, and those are corresponding parts in those 2 triangles. Y'all notice those are at the end of the 2 tick sides. So then we would say that XY is parallel to WZ because of the converse of the alternate interior angles theorem. And WXYZ would be a parallelogram because both pairs of opposite sides are parallel. All right, let's look at the next one. On this one, we have the EF is congruent to GH, and EH is congruent to GF. And we're going to prove again that this, because of the opposite, because it's basically, we're going to prove this a parallelogram because opposite sides are congruent. So this time we have our given information. It's up here. We're going to go ahead and fill that in. Notice here it says EG is congruent to GE. Now I think you guys had EG is congruent to EG, and that would have been the reflexive property of congruence. And either way, it really is the reflexive property of congruence because it's the same line twice. So again, when we're talking about side, 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 now let's look at what should be marked in here. We have now the shared side, right? So you should be able to see why these two triangles are congruent. The triangle on the bottom left and the triangle on the top right. So we're going to say triangle EGF is congruent with triangle GEH. Then we're talking about some parts of those triangles, right? So that's CPCTC. So we're going to say that triangle FEG is congruent to HGE. FEG is this angle right here, and HGE is this angle down here. So those are corresponding parts in those triangles, because again, they're between, and let me put 2 ticks on the shared side. So they're between the 1 and 2 tick sides, between the 1 and 2 tick sides. So we're going to say that a pair of those angles that we just talked about have to do with this side right here and this side right here, because those are the sides that make that angle. Now, if we can say that those are in alternate interior angles position, and they are, and they're congruent, then that means we can say that this side is parallel to that side. So we can say then that EF is parallel to HG or GH. Then we're talking about another pair of angles now, FGE and HEG. FGE is this angle right here, and HEG is here. So now this time we're talking about the other pair of sides. Notice we're talking about these sides right here. And once again, those are alternate interior angles to those sides. So we would have used CPCTC again here for that piece. And then we're proving that those other two sides are parallel by the converse of the alternate interior angles theorem. So that's exactly what we just did. And then obviously we're saying that this is a parallelogram because both pairs of opposite sides are parallel. All right, the last one. This time we're given that AE and DE are congruent and CE and BE. Those are our diagonals. They are being bisected. We can tell that because AE is congruent with ED and CE is congruent with BE. So again, we have some given information, and then we have this angle AEB, which is congruent with angle CED. Hopefully all of y'all can see this right now, that these are vertical angles. So that would be our reason for step 2. Step 3 is talking about side angle side. Well, I must be talking about the top triangle and the bottom triangle if we're using side angle side, because that's the only one I have an angle for. So we're going to talk about triangle AEB and triangle DEC. And again, look at the sides we went across first. 1 tick side to the arc and then the 2 tick side. So we're going across the 1 tick side to the arc to the 2 tick side. Then we have that DCE is congruent to ABE. So let's do this in a different color. DCE is this angle right here. And it says that it's congruent to ABE. ABE, this one. And those would be corresponding angles, right? And then we've got side AB is congruent to CD. AB is congruent to CD. Again, those are corresponding in corresponding position as well. So this would be because of CPCTC. Then down here, converse of alternate interior angles theorem. Remember again that when we have converses, we are proving that a pair of sides is parallel, right? So we have that AB is parallel to CD. That would be AB is parallel to CD by the converse of alternate interior angles theorem. That's what we just dealt with, was a pair of alternate interior angles. So here again, this time it says parallelogram because pair of opposite sides are parallel and congruent. And that's exactly what we just proved.